Okay, so in the last example here, now we're going to work on the writing the equation. So we have given the following information, write the equation of the following functions. And again, just a kind of reminder here, we're given with the, sine function, y equals the sine of x here, derived the sine function. And just remember our different characteristics here. We have a times the sine of b times x minus c plus d. So when we're given certain pieces of information, we need to really understand, is that going to be an A, a B, C, or D based on how it affects the graph. So the first thing is I have an amplitude of 4. Well, then I know that my amplitude is my A is going to be plus or minus 4. Since there's no other reflection going on there, I know it's going to be a positive 4. So I'll just write y is equal to, I'll put this in a different color, 4. And now let's go and take a look. It has a period of 4 pi and a vertical shift up 1. Well, I know D is my vertical shift up 1, so I got that, right? That's just going to be plus 1. The period, though, kind of gets a little confusing, or can be a little confusing. So the easy way I like to look at this is we know that the period of a function is 2 pi divided by b. So I need to figure out what b is, right? So I have 2 pi divided by b, and that's going to be equal to 4 pi. So when I solve for b, multiply by b on both sides, divide by 4 pi, I get 2 pi over 4 pi, which is equal to 1/2. So therefore, I can write this as a 1/2. Let's put that back in red. Write this as 1/2. I don't have a c, so that's just going to go back to x. And then I'm going to have plus 1, so plus a d. Plus d, which is plus 1. So you can see here, my A is my amplitude of 4. Here's my period, my B, which is 1/2, which gives me a period of 4 pi. And then I have my vertical shift up 1. And then we could also rewrite this one more time. That is also the same thing as 4 sine of x over 2 plus 1. So just another way to kind of look at it. All right, so the next one is cosine. Again, we can do the exact same thing, except replace all the signs with cosine. So in this case, we have a phase shift with pi to the right, a period of 2 pi. So that is our initial period. So therefore, we don't need to worry about the b. And then a reflection about the x-axis. So remember, when we're reflecting about the x-axis, that's going to be a negative on the outside. So I'm going to put a negative there. It doesn't say anything about the amplitude, so I'm not going to worry. So therefore, I'm going to assume the amplitude is 1, right, because it doesn't tell us what it needs to be. So let's do cosine. And then a phase shift of pi to the right. So again, that's going to be, if I'm going to the right, then that's going to be x minus pi. So we'll do x, and then we'll do minus pi. So that's going to tell me to shift it pi to the right. And I don't know why I wrote a period of 2 pi. It doesn't really matter because that has a period of 2 pi. And then a reflection about the x-axis. So boom, there we go. Last one is the tangent function with a period of pi halves. Now that's different, right? Is because when we have a period of pi halves, the original period of tangent is pi. Has a reflection about the y-axis and then a vertical shift down 2. Okay, so let's see here. We have a reflection about the y-axis different than reflection about the x-axis. So let's kind of, let's write this in here. All right, so let's do this in the tangent form. So let's do a times tangent of b times x minus c plus d. All right, so we have a vertical shift down 2. So that's going to be a negative 2. Let's see, a reflection about the y-axis, so that's going to be a negative b. And again, the period is going to be pi over 2. So remember that the period is pi divided by b, and that has to equal pi over 2. So when I multiply by b on both sides, this is what I didn't show in my work last time, and then multiply by 2 on both sides, or b, then I would now I'm actually getting confused doing it this way. Pi is equal to pi halves over 2 times b. So therefore, b is equal to multiply by the reciprocal, which would be 2 over pi, and that would just equal to 2. So that's going to be a negative 2. So the 2 is giving us this new period, and then the negative is telling us to reflect about the y-axis. So I have my tangent function. And then there's no horizontal shift left, right. So that's just going to be an x and then minus 2. So let's just rewrite that nicely. Y equals tangent of negative 2x minus 2. So I'm assuming I actually meant to do something different from the period of 2 pi. But either way, basically what you want to do is just make sure you understand your transformations of your functions here, and then basically know where to apply them to understand. And then again, you can always check your work, right? Take a look at these, and then, take a look at the transformations of the functions and make sure they match to the description. But that's it, ladies and gentlemen, for our lesson here on graphing the trigonometric functions. Hopefully that helps. And now we'll get into graphing the reciprocal trig functions. Till then, cheers.